Hey friends, Dr. Liberty here, and let's talk reactions. Okay, so we are in chapter 2 in the OpenStax text, section 2.3, and we have some terminology to go over. Make sure you read what comes before this because there are some important concepts to pick up on, but I want to hit on the highlights of the things that I really want to make sure that you walk away with. If you're not using OpenStax, it's okay. It's a free text. You can go check it out and use it alongside your textbook. Okay, so we have 3 different classes or categories of reactions to make sure that you understand, and everything is built actually on 2 of these. So first of all, we've already used the word anabolic or anabolism. We talked about a building up. So an anabolic reaction is basically the same thing as a synthesis reaction. So now welcome to A&P, where we're going to have 15 words for everything. It's just the way it is. So an anabolic reaction is the same thing as a synthesis reaction. We are building. But now that we're in chemistry, right, we have to use a different word. So if we have A and we have B and we put them together to have AB, that is a synthesis reaction. That is also classified as an anabolic reaction. If we have AB and we break it down into its components, A and B, that is a decomposition reaction. Now, I know you've probably heard these words before, right? You're more likely to have heard the word decomposition than the word catabolism. So now you can take something that might feel a little more familiar and equate it and understand kind of what's going on a little better. So decomposition, of course, decomposing things are breaking down. Great. So if you are having trouble with those, you need to get those 2 words first. If you don't get synthesis and decomposition reactions and understand what's happening there, then we're going to have some problems. So get those 2 first and then build on it. So the next thing to do to build on that is something called an exchange reaction. In an exchange reaction, we're going to have to break something apart before we can build it up. So if we have A, B that come to the party and C, D come to the party together, and they swap partners so that A leaves with C and B leaves with D, that is an exchange reaction. You don't have to have 2 sets of 2. This can happen a bunch of different ways. Yes, it could be A, D, and B, C. It doesn't matter. The fact is we broke apart the one pair, we broke apart the other pair, and they switched partners. I also like the way that OpenStax shares this with words. It's another way of looking at it. Let's see if we can get this to, there we go. So in a synthesis reaction, they take 2 separate words and put it together. They take a word and they break it apart for a decomposition reaction, and then they use the same combination of things to show you an exchange. Now in this exchange, we have, for instance, an A, B, and a C. So we have notebook and worm, and we break apart notebook and put book together with worm. So A is over here and B and C leave together. That is another example of an exchange reaction. There's no rule that says there have to just be 2 partners or 2 pairs that we break up. Chemically, again, this is going to show up in many different ways. So synthesis, decomposition, and put those with words we've already learned or are working on, anabolic and catabolic reactions. Let's also talk about the rate of reactions, and let's think about what speeds up, because this is one of the little learning tips I really like you to know, and I want to make sure I tell you when this is the situation. If you can learn one and know that the opposite is also true. So if we want to think about what's going to speed up a reaction and make it happen faster, then the opposite of that would slow it down. So if a higher temperature is going to speed up reactions, then a lower temperature is going to slow them down. There's no point in learning both of those things. Learn one, okay, I call it bargain learning. Learn one and just know that the opposite is also true. So generally in the body, we would be more concerned with speeding up reactions. And so how do we do that? These are explained very nicely in the OpenStax text, so you can read more there, but more surface area is going to make it easier for reactions to occur. This is really important for things that we talk about in like the digestive system. So that's why we chew foods. Gases, there's also more surface area in a gas than say in something that's solid, because you'd have to break apart something that's solid or break it down in order to have that surface area. So more surface area, faster reaction. A higher temperature, also faster reactions. We'll see reactions slow or stop as it gets colder typically. And again, this is focusing on A and P related things. A higher concentration of molecules. So the amount that's present, if there's more present, there's simply more ability for reactions to occur. And likewise, more pressure. And in pressure here, we're talking about the space the molecules occupy. So if the OpenStax does a really nice example of a dance floor, that's a great way to think about it. In the body, though, if we have a space, the smaller that space, that means the higher the pressure, because we can be affecting air pressure or partial pressures or things like that. So if we have less space, everyone's crowded together, then it's more likely for things to happen. If we're really spread out, so let's think about a 10 by 10 room, right? That's kind of like a small bedroom. In a 10 by 10 room, if you put 2 balloons, how likely are those balloons to interact with each other and come into contact? And you've got 10 feet by 10 feet by 10 feet. That's a lot of square feet for those balloons to have access. Even if we just did 10 by 10 on the floor and we had balloons that you had blown up with your mouth so they don't float, what's the chance that they're going to run into each other? And it's very low. Now, if we have the same 2 balloons, so we're not changing concentration, we're just changing pressure. We take those same 2 balloons and we put them in a 2 foot by 2 foot square, it's much more likely that those molecules are going to interact with each other. So pressure is, think about like the amount of space that the molecules can occupy. The other thing that's really important is enzymes. And again, this is going to speed up the reaction when we have enzymes or catalysts present. Enzymes are going to work as like a matchmaker. They're going to bring the 2 components or the multiple components together. They're going to say, hey, oh my gosh, you need to meet you. And they're going to bring them together. They're going to facilitate a reaction to occur. And then they're going to get out of the way. They don't stick around. They don't get used up in the reaction. They just help the reaction happen faster by kind of matching up and putting the molecules together. One of the important things we talk about is activation energy. And this is probably something you haven't heard before unless you've taken a chemistry class. Activation energy, this confuses people. The activation energy is kind of like when you get on a roller coaster and you have to go up before you can hit the top and roll down. Enzymes lower the activation energy. They make it easier for a reaction to happen. It's less of a hump that the reactants have to get past in order to get to the point where they come together. So enzymes being present help lower the activation energy, which makes it easier for the reaction to occur. If this is something that confuses you, let me know so we can talk more about it. But its activation energy is reading this right here. How big of a hill do we have to, sorry, let's go with the same angle of the graph. How big of a hill do we have to go up in order to, ride downhill? And it's good that it takes less energy because then that energy could be used somewhere else. Okay, so that is section 2.3 on chemical reactions. Those are the highlights I want to hit. Any other questions, as always, please reach out and let me know so I can help you. Watch.